Guys, today we're going to talk about solving inequalities, and the I can statement we're looking at is I can graph the solution set of the inequality and interpret it in the context of the problem. So let's begin. Remember before how we had said that an equation is like a balance. So if I have 10 pounds on the left side, I have to have 10 pounds on the right side. If I add something to the left side but not the right, it makes it unbalanced. It makes it an inequality. So an inequality is an unbalanced statement. So let's go back to a balance, an equation. If I have 10 pounds on each side and I want to keep the balance, I would have to add the same thing to both sides. I could also subtract the same thing from both sides, or multiply, or divide. I have to do the same thing to both sides. When we are solving inequalities, we're going to treat them the same way. If I have an inequality and I want to make sure it stays an inequality 100%, that means I'm going to have to add the same thing to both sides, or I can subtract the same thing from both sides, or multiply, or divide. So I'm going to treat solving an inequality the same exact way I would treat solving an equation. So let's look at the symbols that we have for inequalities. So you already know greater than, less than, greater than or equal to, less than or equal to. But now we're going to add a layer of graphing. If I want to say that my number is greater than 2, okay, I have to ask myself, can it be 2? No, it cannot. So if I wanted to graph all of the values that are greater than 2, I would start with a circle at 2. And that circle is not going to be shaded in because it can't be 2. But it can be any value greater than 2, like 3, 4, 5, and so on. So all of these values, I'm going to use a highlighter or darken here to show the solution to a number greater than 2 is going to be starting at 2 and anything bigger than 2. So we're not going to start at 3 though, because think, is 2.5 greater than 2? Yes. Is 2.000001 greater than 2? Yes. The same rules are going to apply with less than. Okay, so if a number is less than 2, I'm going to think, okay, well, can it be 2? No, it has to be smaller than 2, but it can be 1.9999999. So it can be 1 is less than 2, 0, 1. So now in this case, I'm going to highlight the number line all the way to the left. Now, here's where we're going to change it up a little bit. When I get to a value like greater than or equal to a number, okay? So let's say I want to graph all the values greater than or equal to 2. Now I ask myself, can 2 be part of the solution? Yes, because I said it can also equal to. Therefore, I'm going to shade it in, okay? And I'm going to highlight all the values that are greater than 2 as well. If I want to do less than, same thing. If I want to know all the values that are less than or equal to 2, I am going to have a shaded in circle because 2 is equal to 2. And all the values less than 2, which are also included, go to the left of 2. So now let's look at how we use that to solve problems. So we're going to start off today just looking at simple one-step inequalities because we're adding the layer of graphing. So if I wanted to solve this inequality, x plus 5 has to be greater than 11. I'm going to imagine it's an equation and solve it the same exact way. I'm going to subtract 5 from both sides and get x is greater than 6. I can check that by plugging it back in. Is 6 plus 5 equal to 11? Yes. But I don't want 6, right? I want all the values that are greater than 6. So I'm going to have an open circle at 6, and I'm going to graph all the values that are greater than 6. Here's another one. x minus 2 is less than or equal to 5. I solve it like an equation. I'm going to add 2 to both sides. I'm going to get x is less than or equal to 7. Can x be 7? Yes, it can. So I'm going to make a closed dot at 7 and shade all the values that are less than 7, so going to the left. When I have multiplication in the problem, how do I solve it? I have multiplication, I need to do division. So in this case, I'm going to divide both sides by 3. I'm going to get x is greater than 4. I'm going to put a circle at 4, but I'm not going to shade it in because it can't equal 4. And I'm going to go shade to the right. Now I can check these. I can check to see if I've shaded the correct way by plugging it back in. 5, let's think about it. What is 3 times 5? Is it greater than 12? It is greater than 12. Oops. Oh no, sorry about that. Okay. It is greater than 12. So, oh my gosh, I'm sorry guys. All right, I'm not going to be able to subtract that. So I get 15 is greater than 12. Because it's true, I know I've shaded in the correct direction. With division, to undo division, I'm going to multiply both sides by 4. I get x is greater than 8. It cannot be 8. It has to be greater than 8. So I'm going to put an open circle at 8 and shade to the right. And I can try that out. Think of a number greater than 8. How about 12? Is 12 divided by 4 going to be greater than 2? Well, 12 divided by 4 is 3. Is 3 greater than 2? Yes. Now I know shading to the right was the correct thing to do. We are done with this video. You can go back and watch any portion as many times as you need. But don't forget to WSQ in your notes.